Good morning, everyone. I'm Jessamy Garcia and your science teacher for today. Everybody is requested to stand for our prayer. Father God, come with us today. Fill our hearts with joy. Fill our minds with learning. Fill our classrooms with peace. Fill our lessons with fun. Fill our friendship with kindness. And fill our school with love. Amen. Our lesson yesterday is all about comets, asteroids, and meteors. Let us review first what image is all about. This image is all about comets. This one is all about meteors, and this last image is all about asteroids. Now we are going to proceed to our new topic is all about, which is all about Newton's laws of motion. So here are goals or objectives. First, define what are the three laws of motion. Second, compare and contrast the three laws of motion according to Newton. Third, create an infographic presentation about the three laws of motion. Fourth, perform an activity relevant to these three laws. And last, value the importance of the three laws of motion by showing an active participation in class. So, do you have any idea what are the three laws of motion? So, Sir Isaac Newton in the year 1643 to 1727, an English scientist and mathematician famous for his discovery of the law of gravity, also discovered the three laws of motion, which are the law of inertia, law of interaction, and law of acceleration. So Newton's first law of motion, also called as the law of inertia, states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary or not moving. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. So just like for example, if a car moving at a constant speed, it will continue moving unless there is a force acted upon it. And the Newton's second law of motion, or the law of acceleration, states that force is equals to mass and acceleration, which is a measurement of how quickly an object is changing speed. So in this law of acceleration, there is a constant speed or changing speed. The word itself is speed. So imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine we make the ball twice as big. It will become double mass, but keep the acceleration constant. Force is equals to mass times acceleration says that this new ball has twice the force of the old ball. Now imagine the original ball moving at twice the original acceleration. Force is equals to mass times acceleration says that the ball will again have twice the force of the ball at the original acceleration. So the last law, or the third law of motion, also called as the law of interaction from the word action and reaction, states that for every action there is an equal and opposite reaction. For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law of motion says that your seat is pushing against you with equal force. This is why you are not moving. There is a balanced force acting on you, gravity pulling down, your seat pushing up. Just like for example, the wall and you are the same position, but it different direction. So try to differentiate the three laws of motion. The first law, every body remains in a state of rest or uniform motion unless acted upon by a net external force. The second law, the amount of acceleration of body is proportional to the acting force and inversely proportional to the mass of the body. Just like this equation, force is equals to mass times acceleration. While the third law, for every action there is an equal and opposite reaction. If an object A exerts a force on object B, the object B will exert an equal but opposite force in object A. So we are going to cite example of the three laws of motion. But first, we are going to cite example in the first law of motion, which is the law of inertia. So this image states that an object at rest will remain at rest. Then, unless acted on by an unbalanced force, then an object in motion will continue with constant speed and direction. Then, unless acted on by an unbalanced force. There is a presence of unbalanced force in the first law of motion, which is the law of inertia. So the second laws of motion example. Newton's second law, if you apply more force onto an object, it accelerates in a higher rate. Just like what I have said, for example, there is a force U, the person, then the object. It is going to accelerate in a different direction. While if you are undergo more force, then there is a tendency of more acceleration will be goes. While the third law of motion, which is the law of interaction, example is just like this. This is body 1 and body 2, which is the undergone reaction and action forces. So it's time to activity. So title of the activity, take it low, low, low. So the duration is 15 minutes. The objective is to create an infographic presentation showing the differences of the three laws of motion. Second, to cite some examples of the three laws of motion, and lastly, to identify the three laws of motion from the pictures provided. So this we are going to answer lately after my presentation. So here is the rubrics. Accuracy of the activity, which is 5 points. Organization, 5 points. Time or duration, 5 points, which is the total score of 15 points. So what are the three laws of motion? What are their similarities? What are their differences? So, direction. Think well and answer the question correctly. Write true if the statement is correct and false is if otherwise. So, you're going to answer this also after my presentation. So, here is your assignment. Research about the persons responsible for the development and discoveries of the three laws of motion. That's all. Thank you.